Hey, Kevin. Hey, thanks so much for joining us in the car for our little tour of Amsterdam. And we can talk a little bit about Kubernetes and, software while we go. Do you wish to, or could you introduce yourself to the listeners?
Yeah, thank you for having me here. I'm Kevin Wang. I actually started my contribution to upstream Kubernetes back to 2015.
Oh, wow.
And I used to do a lot of around the scheduling part. And also since 2018, I started to working on a little bit more about Kubernetes to the industry stuff. So one of the projects I initiated was KubeEdge to basically leverage the Kubernetes and cloud native applications running on the edge computing environment in scenarios. And also later on, another kind of path is that there are a lot of AI, machine learning, big data workloads trying to run on top of Kubernetes. And we have seen that actually, Kubernetes is more likely born very well supporting the microservices. So we built the Volcano project to kind of porting the job management, the queue stuff, and the GAN scheduling to better leverage the batch AI machine learning workloads running on Kubernetes.
Gotcha.
Yeah, and actually I also have a little bit background about the multi-cluster, multi-cloud part.
Oh, okay.
I'm a participant of the multi-cluster SIG in the early time when it was called the Federation. And also after two versions, Federation V1 and the KubeFed trying, we started actually the V3 project. It's called the Kamada, and also it's a sandbox project in the CNCF. Yeah.
Gotcha. So when I was kind of doing some of the background research, my immediate thought is okay, KubeEdge and Volcano, are they related somehow? That in your mind, they seem to not be connected really. I mean, both interesting, but do you see them as somehow paired together, and that's why you're kind of working on both?
I think not especially from the user perspective, maybe not quite connected. Especially the typical user of KubeEdge, it's more from the industries like manufacturing, public transporting, or the other people building the smart campus, for example. While the user of Volcano are more likely the academics, research organizations, or some just running the machine learning, big data trying on top of Kubernetes. So a little bit of the connection, we think that there are a lot of AI workloads exploring to the path to run on edge.
Gotcha.
And people are talking about in the future we may have some kind of redundant resources that it can be used in the nights for training. For example, a lot of EV, they are become more and more smart, but in the nights it's kind of the resources are just
sitting there.
Yeah. So that's kind of future, but from now it's kind of still two projects doing their own stuff.
That's interesting. So yeah, kind of old school grid computing kind of scenario where you're hey, maybe we could use some of these resources to when they're not being used for other things. That's interesting. So with KubeEdge, what do you think, and this is kind of the nature of this show, right? Is what do you think is the thing that you think looks really interesting about it in, say, a 6 months or a year? What's the next thing that's going to drop that you think looks really, really cool?
Yeah, actually, I think the exciting thing in the KubeEdge is, especially from the community perspective, there are a lot of new usage, new ideas, kind of adopting, especially on the edge that is keep moving. right? In the early days, we start this project. We are more likely focusing on the fixed location edge, like the kind of some of the devices.
Like a thermostat.
Yeah. And also some of the manufacturer, they just deploy their applications with KubeEdge in their factory, in their workshop. But during the last 2 years, one of the academic they try to manage workloads on the low orbit satellite.
Okay. Yeah. Those are definitely moving. Yeah.
Yeah, and it's a low orbit. It's actually moving very fast. It's like you got 6 to 10 minute time window to stay online.
Yeah.
And
then you have to wait again.
Yeah. And it's like each day you will have like 8 to 10 times got this time window, and the resource on the satellite is quite limited. Especially they're using the battery, solarized battery. So it's kind of we need to save the battery so the satellite can serve longer.
Right.
Yeah, and
keep being a satellite.
yeah. And sending data to the ground, it's kind of cost a lot of battery usage. So that academic, they are trying to have some small model running on the satellite to do some like easy analysis to filter some of the input data, so they can send the most valuable
data back rather than all of it.
Yeah,
that's interesting. I bet that is a hard decision to get to as well, right? Because one of the fascinating things about data in recent history, right, is that people are collecting everything because they don't know what might be useful in the future. So that's a especially hard problem, right? Because it just disappears, right?
Yeah. So another very interesting usage is that one of the actually the automotive manufacturer, they use KubeEdge in their EV. The starting mode was to write in one of the MPV because it's a kind of more have more resource there. So they are exploring the path of enabling the SOTA, basically the software level upgrading.
Oh yeah.
Because before that they have their own kind of FOTA. It's a firm upgrading, but when you are upgrading the firm, it's kind of the car need to stop there, wait the whole upgrading finished, and you can go. Right. But it's kind of take a long time, and a lot of actually unrelevant thing need to be stopped. But the software level give you kind of smaller component to be able to
update. So you can do like smaller chunks at a time. And so they're looking at KubeEdge to kind of deliver those updates in a sense.
Yeah. And that's kind of just a very starting usage. And also we know that in China there are kind of companies exploring the kind of the charging, especially changing the battery. So they have their own station there, and they are exploring the scenario like when your car goes to near the station, they want to use some of the local network to guide your car to the right place. And also during the changing of the replacing the battery, you can also trigger some of the upgrade of the software.
Right. You can use it as an opportunity for basically fast data transfer, right? That's interesting. And so is that what you've been kind of focusing on from your work perspective in KubeEdge itself, or is that just something that is going on that you think sounds really interesting?
So currently we are collaborating with these users to implement that. For example, satellite, they have already some of the satellite running in orbit already, but they want to kind of improve the whole platform to make it much smarter. And also, like the vehicle, currently the in-car deployment is already there, but the charging station is kind of a new idea on the way. Yeah, and from my perspective, we are kind of trying to decouple different things, because KubeEdge, from the framework layer, we want to keep it more general and open to more of the scenarios. At the same time, we want to kind of provide more functionalities to help people simplify their adoption. So there will be some like toolkits fit to each part.
To kind of enable the consumption of these new features. That's interesting. And I mean, a lot of the problem with, especially incredibly sophisticated software like things like KubeEdge, right? Like, is just getting people to wrap their head around what it's going to do for them or how it does it or whatever is often half the battle, right? So I was curious also about Volcano, which I thought was interesting project. Can you tell us, give us a little more detail on what Volcano does and what it's for?
Yeah, at the very starting point, actually we were building the GAN scheduling. That's kind of the first requirement of all these AI machine learning end users. And we know that in Kubernetes, it's kind of scheduled pod by pod, right? But for example, the TensorFlow, people want kind of have a column of the PS, the parameter server, or the worker node start, then load the data to start training. If only few instances there, it's kind of waste of the GPU, especially GPU time. So we introduced the pod group concept and also the Volcano job concept to support multiple the AI framework definition. It's kind of, you can define the TF kind of cluster or torch.
And it'll basically modify the scheduling, for example. Per for that set of things or whatever. And
also actually for the kind of traditional batch user, they are very familiar with queue functionality.
Like batching up your work.
So we also imported the queue concept and build like the hierarchical queue, and also implemented some of the algorithm that's quite familiar to the batch users, like fair sharing or bin packing, to kind of also balance the resource usage. And recently, what we are doing is to implement like the better resource sharing, taking the especially the online services and the batch workloads both into consideration, enable them to co-locate on the node, and also to provide the subscription of the resources. Also we are actually collaborating with the open operating system community to kind of achieve the node level resource preemption.
Oh, interesting. Okay. So I was at a thing or whatever, and so are you using things like eBPF? Like eBPF to do, like, how are you communicating with like the OS level from inside Kubernetes? Like what technique is it using?
Yeah, so actually, when it's like the whole system, majorly we have two part, like scheduling level. It's like we need to schedule according people requested, right?
Right.
And the people are able to declare like I have like 2 gigabytes. That's kind of not exactly using all the time, so it can be reused if I'm not in a heavy load situation. Yeah, and then when we are creating this container and on the node, it's like we need to do some of the annotation to through the CLI to tell the basically to tell the OS when you are creating, you are allocating these resources, you can put some of the part of the resources being shared.
Right.
So we let user to define the different priority of their
of the batches or whatever,
workload basically, and also define what kind how much they can share their resources, and then we will just put more like low priority workload there. The role what OS do is that they make sure the part of resource can be shared to the lower priority workloads. But when the pressure comes to the higher priority, the OS needs to
be able to preempt, basically.
Take back the resource very quickly.
Right.
Yeah. And the you know that the interesting thing is that the sharing among CPU time it's kind of much easier. But for the memory, it's kind of more interesting because memory it's kind of not easy to compress or
Right. Well, and there's a lot. There's also a much larger like security component, right? Like because you don't really want this process to be able to read that process's memory, right? And so that can also be a bit of a challenge.
So what the OS team they are exploring is that like they will check basically determine which application is kind of running, and also they can use like pages to kind of save this memory and compress it and store it on the to the disk, and later on resume it to the memory.
And so you were saying before that you can kind of implement a different scheduler for different types of like AI approaches or whatever. Can you do it per workload, or do you do it for the cluster, or like how do you like at what level is the scheduler kind of going in?
At the very beginning we just replace the scheduler, but at the same time we are kind of relying the multi-scheduler mechanism from upstream. We are also contributor of that. So basically you can for each workload, I remember there is actually a scheduler name field. So people for the user they can just determine which scheduler this pod gets scheduled.
Right. Okay.
Yeah, and also for Volcano, actually it's kind of we don't want we don't think that multiple scheduler running inside a cluster is a good idea, because you kind of have two brains to make decision. Right.
Yeah, they're gonna like fight, right? That was actually kind of why I asked the question, because I was curious, how do you make them play nicely together?
So currently we actually import the upstream scheduler algorithms. So basically scheduler is kind of superset of all the functionalities. So you can also use Volcano to schedule the microservice project pod.
Okay. So you can do other types of batch processes besides kind of like the AI work, right? That's cool. It's funny because yes, I'm very familiar with the batch process kind of for research, because I'm a professor at Boston University, and we have this whole research computing cluster, and it has like all the batch processes and stuff. And it's kind of like I didn't know about Volcano before, and so now I kind of want to go back and I actually communicate with those folks a fair amount and kind of be like, hey, did you know about this project over here? You might find it really useful, rather than, because I'm sure they're maintaining their own scheduler right now, or the batch scheduler, not like scheduling scheduler. So yeah, that's super interesting. I really I'm glad to kind of hear about it. So what do you think the next cool thing is going to be in Volcano? Like, what do you think the next big feature that you really want to see land?
Actually, recently we are taking a look about the multi-cluster part.
Okay.
Especially for the Kamada project, we already did some kind of trying, and also some basic implementation about scheduling the workload among clusters.
Okay.
I think that's a kind of very new area, because people today, the way they use multiple scheduler, they are just kind of manually picking the cluster to run.
Where to put the work.
And especially for kind of the batch users, they just want resources. They don't care about whether.
Right. I don't care where it comes from. Just let me know when it's done. Right.
So actually, we already have a very basic implementation in the Kamada project. It's kind of help you automatically divide the replicas to multiple clusters according the resource availability. And also, the most interesting thing is that people today, they want to take the quota into consideration, take the price of the underlying resources, like the different cloud, they have different price for the CPU, memory, GPU. Right. So they want once they kind of imported this perspective into consideration, they can get cheaper.
They can actually use part of the scheduling is not necessarily finding the most optimal place to run it, or part of optimal includes price, right? Which is kind of I think a new thing in kind of all of our computing, where it's like we need to work in the price point, because we're not used to all this like public cloud and everything else, where it's like you pay per minute or whatever, and that now you want to build that. We probably should have been building it into like all of our data centers for all these years, but now that we really have to, because we really care about the pricing, it's interesting how much of it's become part of the schedulers and that kind of stuff. There was actually a guy who's working on his PhD at Boston University, who was working on tooling or trying to figure out how he can essentially do a scheduler for serverless functions, so that the serverless function would kind of like move around onto the different clouds based on price point. And so can you optimize with that without the some sort of massive performance impact? So I just think it's all kind of really interesting to look at it from that perspective. I've always thought schedulers were really interesting, and so the more, especially when they're really complex. What I wanted to ask you about the multi-cluster, so in the multi-cluster scenario, you kind of already were saying that it's not great to run multiple scheduler types in one cluster. So do you, now when you want to identify where to put a batch load, can you kind of indicate, does a cluster then decide, what, we're going to go all TensorFlow because we have a lot of pent-up workload instead of whatever other scheduler we are on, and so that it can pick up those workloads? Like, are you going to be able to modify or think about modifying kind of the cluster itself as part of the activity of balancing the workloads across the clusters?
You mean modifying the clusters?
Yeah, so like, okay, multi-cluster scenario, right? And each of the clusters is probably running some scheduler, right? We don't know what in advance, right? But our batch, tools or engine or whatever, is saying, hey, you know what? I've got a lot of TensorFlow stuff coming along. You cluster over there. You're not really doing a ton of stuff. So can you modify your scheduler to be the TF one so that I can push a bunch of that workload there? Because I think that's really interesting.
That's why actually we are trying to do a more kind of powerful version in the Volcano project, because we are expecting people to kind of use Volcano in the single cluster as the scheduler, because it's able to schedule the batch workloads as well as the kind of classic Kubernetes applications, right? And also actually we already seeing a lot of challenges doing the two-level scheduling, schedule to cluster and the cluster do their job, right? And actually you cannot always make sure the federation level scheduling is correct or is the best, because there's always some race condition, and the federation layer the scheduler see there's some resource available. Also, we can take kind of the resource fragmentation into consideration, right? But the underlying in cluster scheduler, they are also doing their own work. So the things can be changing. So what we do today is that we have a kind of descheduler at the federation level to kind of you know, get things fixed.
Like leave me alone so that I can do proper scheduling.
But you know, it's we think it's kind of expensive, because it takes a little bit time and computing steps to make sure to find out which cluster or which set of cluster to run these workloads, and some of the actually the replicas may fail, and then you come back. It's kind of it's a long cycle, right? So that's why we think that maybe we provide a multi-cluster scheduling functionality from the Volcano, and make the kind of federation layer scheduler and the single cluster scheduler collaborate with each other more closer, will resolve this situation better. Especially we want to improve the kind of the accuracy of the first time scheduling. Well, I mean, you know, schedulers are interesting, right? Because one of the things that is a challenge is like you can't spend so much, you know, processing, you know, power doing the perfect schedule such that it actually uses up whatever optimization that you know we're going to get from your perfect scheduling, which I always think is, you know, it's weird when you have to write software that is going to, you know, optimizations are sometimes at the expense of developing the optimization, you know, which I think is kind of cool. Yeah, that's neat. I think a lot of that stuff is really interesting. And then you mentioned there's a third project that you've been working on. Kamada.
Oh, right. So so multi-cluster management, but you're mostly thinking about it in terms of like scheduling rather than like kind of like you personally from like the scheduling kind of scenarios rather than you know, how do you manage a large number of clusters, right?
Yeah, actually, for the Kamada, we are thinking that people have different kind of progress of using the multi-cluster architecture or multi-cloud architecture. Especially for the very beginning, the very beginners, they just want to reduce some of the repeating work, like spinning up clusters. Spinning up for the cluster lifecycle management, we have the cluster API already, right? But there are a lot of work when the cluster is there. For example, configuring the namespaces, configuring the RBACs, and also setting up the quota for different teams, right? So the idea of Kamada is that we, for this level, we want to kind of reduce the work from the admin perspective. So Kamada provides some of the mechanism called the propagation policy. So it's basically able to propagate any type of the Kubernetes resources, including the custom resource.
Right.
Yeah,
Okay.
so people are able to like propagate RBAC configurations, configure maps, namespaces or resource quota, and as well as the deployments. But for deployments for the slave set, we are able to kind of compute the resource consumption of the pod from the pod perspective to make sure you get appropriate replicas of the application running in different clusters.
Right.
And also like today, actually, when people accessing multiple clusters, the management of the kubeconfig is actually a big challenge, both from the user perspective and from the admin perspective. So Kamada also provide the kind of unified entry point to multiple clusters. From a little bit the implementation perspective is that we use the impersonate mechanism from the HTTP protocol. So it's kind of actually the underlying from the user. It's like I will use one of my kubeconfig token to access all the clusters through a single entry point. So I just need to select which cluster I want to go, but I use the same kubeconfig, and the Kamada use its own token actually underlying under the hood to connect with the underlying cluster, but impersonate as the user. So it means that any request going to the underlying member cluster, it's authorized as the user.
Oops.
Yeah.
Sorry, I just I thought that was a stoplight and the guy was right behind me. Okay, yeah. So continue. So basically, you can actually, if you use the kind of the impersonate, right, you can kind of audit and have an idea of who's doing the work to make the changes, right?
Yeah. So from the admin perspective, it's super useful because you got a single point of the entry for all these kind of users or application operators, right? So you can audit just there, and you got unified authentication authorization. It's much easier to manage. To
manage it over, exactly. No, that's cool. So let's kind of ask a slightly broader question. What what got you into like open source and kind of Kubernetes? Like, how did you get started? Kind of working in this space.
That's a very interesting topic. So in the early days, it's like we are trying to build the platform as a service product internally, but later on, actually our team, so Huawei decided to do the cloud business, and so we started to building services for our customers. And actually, before Kubernetes, we also tried some of the other technologies. But Kubernetes is the first one that we see a very open community. In the early days, like back to 2015, the scalability is like 500 nodes, right? And there are a lot of scheduling features to be added, and so in that day I kind of very fortunately joined the community to discuss with the people about our idea, and we got very short time for the ideas to be accepted, and we started contributing. Right. So that actually kind of experience affect us a lot. So we actually benefit a lot from collaborating with the upstream community. And that's why when we are building the new services, we also open source it.
Yeah.
And then donate it to CNCF.
Yeah. So that you can kind of benefit from that. So that was your personal first foray into open source in general?
Yes.
Oh, cool. That's it's a great opening story, right? I mean, a lot of times, your first entrance into open source is because you have some sort of problem, right? But it sounds to me more like you were, you kind of had, hey, we think you've got the right solution. If we can, kind of make this work for us, it'd be really cool. That's awesome. So your organization has done heavy adoption of Kubernetes kind of internally as well?
Yes. Yes. Well, we actually there are also kind of internal internal customer.
Mm-hmm.
They have a very large scale deployment of the Kubernetes.
Mm-hmm.
So actually, from our perspective, we are trying to provide the best solution. So actually, the internal user, they are using the same version we offer to the customer.
Oh, cool. Yeah. So it's, when I was at Red Hat, we used to refer to it as eating your own dog food, which I would say is probably a relatively common phrase, but I think it's always such a good idea to, if you're first customers of your software, it makes it, a lot less painful for your customers, So.
Yeah, and especially I think one of the interesting things that recent years, more and more customers also collaborate with us on the open source.
Mm-hmm.
So it's kind of not just using the commercial part, but they also have some idea. They also have some requirement.
Right.
Actually, they are not kind of 100% certain about their requirement, especially from the solution perspective, right?
Right.
People are always kind of trying to avoid falling into some XY problem situation, right?
Yeah.
In the community, we can discuss with more people and to come up with a more general solution.
Mm-hmm.
So I think that's also a very exciting thing.
Right.
So today we have a lot of features. Actually, the idea is coming from one of the end users or one of the service providers in the community, and we discuss together and implement it together.
Yeah, that's awesome. Well, why don't we end the interview there? Thank you so much for taking a little tour of Amsterdam with me. I hope you enjoyed it. But it was a pleasure to talk to you. I like I said, I've always been fascinated by schedulers, so I really like talking about them, even though I've never actually worked on any. I get really interested in technologies that I don't actually do sometimes. So thanks again. I really appreciate it.
Thank you.